Let's look at the fourth example problem in topic 1. So in this problem, we are making acquaintance with Professor Goldluck. We have 6 problems as of now in topic 1 and topic 2 in which Professor Goldluck play an important role. So in this problem, so in all the Professor Goldluck problems, Professor Goldluck is trying to buy a house. So in this problem, the house he wants to buy must have at least 4 bedrooms, is at least 2,500 square feet, and it costs no more than 400,000. I guess from these numbers you can see the professor living a place with a relatively low living cost. So he prefer houses that have a low price per square foot. So he considered those has a higher value. So let's call this the PPSF index, so price per square foot. So this problem asks you to compute information for the 2 houses that satisfy all the conditions, and among the houses that satisfy all the conditions have the lowest PPSF index values. So it should be fairly straightforward. So in this problem, we are not, you don't need any new language features. So all the sort of C++ language features that you will need to write one solution for this problem are already introduced. And in fact, most of the ideas are also introduced, so I encourage you to try solving this problem yourself first before moving on. So the problem asks us to find the 2 smallest. So we already talked about how to find max, how to find min. So how do we find the 2 smallest? So we do that by using 2 variables, storing the current smallest and then the second smallest. And then every time we see a new value, so in this case new house with a new PPSF index, we will first compare that with the min. So we store the minimum PPSF we've seen so far and the house corresponding with it. Now, if the current house has a lower PPSF, then that means the current house is the new mean, and the current mean becomes the second mean. So we basically first set the means information, the current minimum house information to the second mean, and then we set mean to be the current. Now, if the current house we are looking at has a PPSF that's not less than the mean, then we need to compare it with the second. And if it's less than the second mean, then that means we find a house that's sort of the new second best. So we need to record that information. So the last few lines on this slide illustrate the example. Suppose we have a mean value of 8, second mean of 10 as of right now, and the next one we saw is 5. And because 5 is less than 8, so then the new mean should be 5 and new second mean should be 8. So we will assign second mean equals mean and then mean equals the current. And suppose in the current state we see 7, then 7 is not less than 5. So then we compare it with the second mean with 8. It's less than 8, so that should replace the second mean. So that's the idea of finding the 2 smallest house. And these slides give the code. So I define the constant using a macro to define max PPSF to be some number that will be largest than any PPSF value we're going to see. And this PBF stands for price, bedroom, and footage. So this P1, B1, F1, and PPS1, they store the information of the current house, the current means of the house that among all the ones we have seen so far has the lowest PPF index and of course satisfy all the conditions. And P2, B2, F2, these are for the second minimum house. So we repeat, we read in the data, and then here we check satisfy all the conditions. And we only consider a house if it satisfies all the conditions. If we do, if the house does satisfy all the conditions, we compute PPSF and then we compare with the current mean. If it's less than it, we need to sort of shift. We first shift the current minimum to the second minimum, and then we set the current minimum to the current house. And if that's not, if the current house PPSF is not less than PPSF 1, the current minimum we compare with the second. So finally, we need to output after we've computed the house information. So here the output is also a little bit sort of complicated than the previous problems, because the output will depend on how many houses we have found. So if no house satisfies the condition, then we are supposed to print you're out of luck, Professor Goldluck. It may be that there's only one house satisfy the condition. In that case, we just print information of that house. If there are two or more houses that satisfy the condition, then we should find the two best. We just print the best and then the second best. So the one thing I want to mention here is we do not need to use an actual variable to store whether we have found the first house or the second house, because that information can be inferred from the PPSF value we have stored. So in fact, actually, it can be inferred from any of the variable we use to record house information. So we could have used the P1 equals 0 here. So essentially, we're trying to see whether this set of variables for the first house has ever been updated. If it has not been updated, if the P1 has not been updated, that means we have saw no house that satisfy all conditions. So PPSF1 is still max PPSF, and all the other variables should be 0. So we can check the status by using these variables instead of using an actual variable to store the information. And similarly, if we have the first house information is there, we can check whether the second house information is there. So if it's not there, then we'll just output one house information. Otherwise, we output two.